Uh, Again, welcome back, and I hope all enjoyed your holiday. We are going to about to finalize this summer course, and the last chapter in this course is about how to design, how to calculate the loads that we have for the water and the wastewater and the hot water in the buildings and inside the buildings, which is called by plumbing system. So plumbing system, we have in our houses that like this. This is a typical house plumbing system. I'll show it to you. You can see here's the main typical what we call it as a uh, plumbing system. We have a boiler here. This is a boiler. Here's a boiler, and here's we have a washing machine. I mean by the washing machine, usually it will be used for, um, let me say, a dress washing machine, and sometimes there will be dishwashing machine. Others, we have utility sinks that sometimes we need to have some kind of sinks like this. And also we have for the kitchens that you can see, we have a sink, we have a dishwasher machine here. So, and here's we have for the bathrooms, we need to have a sink, toilet, bathtub. Now, you can see there is a hot water, which is hot water pipes, which is colored in red. So for each fixture, this is called fixtures, we should submit the supply, the water, hot water from the system of this house, which is we have a boiler here. So we should submit hot water to the utilities, and we have to have at least the cold water. The cold water, you can see, it will be submitted directly to the fixture themselves. So there will be the blue one is going to submit to the each point. So for each point, we should have, unless it's not required, like for the toilet, we don't need to have hot water. So the others, we need to have hot and cold water. So here's the one. Yes, you can see this is the hot water. And besides of these waters, this is for pipes. This is for water. We have for the sewage of this. For the sewage, we have also pipes, which is called inside buildings sewers. Here's the sewer system. So you can see also we have to have the sewers have their slopes, and maximum slope, it will be the maximum slope for the houses, it will be 1 centimeters per 100 meter. Okay, so that's all the which is, I think it will be how much? It will be 1 centimeters per 100 meters. It will be 1.001 percentage. So this is minimum slope. Okay. Now usually we have to have this kind of slope, and this is for the sewers. Also, we have to connect for each of them another pipe, which is used for ventilation. This is ventilation. So ventilation pipe, it's also another kind or another requirement for, another requirements in designing the plumbing system. So briefly, we have a hot water cold water, and sewers. The water system, and by the way, we are as a civil engineers are related mostly with the hot water and the cold water and the sewage. But the mechanical engineering are related with the other parts of the plumbing, like AC, a heat ventilation and air conditioning system, HAVC, which is related to submitting a hot air and cold air to the system of the, and which is also a part of the plumbing, but we are not taking that one in this chapter. It's mostly related to the mechanical engineering. Now, do you have any question regarding this picture? Because we want to take, this is the typical one. Now, what should we do? We should design a water for this system. We have typically two systems of submitting water and hot water and sewer for the buildings. We have either it will be pressure system. Pressure system means that you don't need to have a roof tank or elevated tank. It's called roof tank. So in this pressure, you just need to have a booster pump, and the booster pump will take water from this tank, which is the ground tank, and there will be there will be submitting for each of the floors with a pressure. Now, whenever you open the tap, there will be water with a pressure. And if you want to ask how much is or the duration of this booster pump will take to work, there is a sensor of the pressure sensor, drop pressure sensor. If you are using water here, then there will be relief of the pressure inside the systems. Then after relieving to a certain amount, which is not recommended to be the pressure less than this. Now, for example, it's not recommended to have a pressure less than 180, one bar. Then what we have to do, or what's the automatically this pumps, there will be a pressure switch pump, auto switch pressure, which is working with the sensitive to the pressure, and it will turn this booster pump on. Then it will work and it will cover the released pressure, and it will make increase the pressure inside the system until it will get the one that you needed to have it. And then with regular pressure or the needed pressure, it will turn it off. So there is a switch, automatically switch off and on. It will be here. Now the other one is we have to have a tank, and there will be the water will be raising directly to the top of the buildings, and then by the gravity we will have the water to the building. This is called receiving tank type water supply. So we have this type and this type, and there is no more two other between these two types. Now we have here in the most of the houses that we have such kind of this type, and for this is the old one, and for the apartments we have this kind, the pressure surface water surface system. Okay. Now, let us talk about what is the cold water plumbing is. The cold water plumbing is the system for sending or not is the sending cold water to the building, and it will include pipes, fittings. I mean, by the fittings, we have elbows, we have 90-degree elbows, Y elbows, we have valves, and we have fixture. This fixture, look at this one. I mean, by the fixture means what? Fixture, it means that if you have a sink and if you have, let me say, dishwashing machine, these are two different things, two different machines. we cannot say how much it will be. They need it together because this is will be. But there is a standard that you can combine between them. You can say if I have a sink and I have a dishwasher together, so I can say there is a certain amount, or we can do it in a fixture unit. This is called fixture unit. FU, a water fixture unit, or cold water fixture unit, water fixture unit. This is a unit like meter, like kilometers. So fixture units is used in plumbing, So what we have to do, we have to see if that sink is how much it will be designed for using water. So we have a code which is called International Plumbing Code. This International Plumbing Code can manage, or it will tell you how much it will be needed for the using of what is the appliance that we have, and how much is they will need water in terms of fixture units. And I sent you a few papers, or what we needed in design of the plumbings for our chapters, paper from the whole book. There is an international plumbing code. It will be a whole book, but I just copied and send it a PDF file, which is just regular ones, or just what I needed for that. And by the way, here's the code. This one. There is type of the fixture that we have. For example, if you have a bathroom group, it means overall group, which means this. Here's the bathroom group. This is called bathroom. We have a bathtub, toilet, sink. So this is called bathroom cup. And here's bathroom group. This is private, means private, personal. Private occupancy, it means that do you want to, or you are using this for your own purposes, or it's in public. So public one, like we have in hotels, like we have in restaurants, these are all, it's called public use. But if you want to use it for your personal, for example, for your own house, so this is it will make a difference. A bathtub, for example, I will take a bathtub. If you are using the bathtub for your personal, it means in your house. So there is, if one bathtub can be can be for the cold water, it will be accounted as one fixture unit. So if I have one bathtub, it will be one fixture unit. This is one. And if I have one toilet in this group, and this is the one toilet, one water closet, and here's water closet. This water closet, because I'm using for private, and it will consider it as a 6 fixture unit. What that means, it means if I have both toilet and as I told you, a bathtub. So if I have link it together, let me make it here. Let me say if I have both toilet, for example, if I have this one, this is a WC, or this is a water bathroom, and we have a bath type, bath tub. So if I have both of them in one room, so if I want to send water, this is cold water. So how much is the Q? How much is the Q for these two ones? So we have first to convert one water closet is equal to how much fixture units. Will be from the table. from the table of what International Plumbing Code, it will tell you how much is this fixture units will need. You should go to the table. Here's the table, and you should find the water closet. So the water closet I'm using for what? For the private one. So it will be 6 fixture unit. Why? It's for cold water. This is the load, water fixture, water supply fixture unit. Now you can see there's another one, also water closet, but it's private, but it's flash tank. So we have 2 types of water closet. One is called flash tank, one is called flash valve. What's the difference between them? The flash tank is the one that you have a roof in the building. Let me say in your house you have a tank, roof tank, let me say, and it's linked to the tank. There is a flash tank, it's called. Another one is called flash valve. Flash valve is the one that you are using the system of the flash valve. So when you are using this water closet, you have to check whether it's flash valve or flash tank. Then if it was flash valve, it means that it will just automatically, just you are pushing a button like we have, and the system of this building is a flash valve system. So you need to know that this water closet will use 6 fixture unit. What they call the 6 fixture unit. Now,
Doctor,
yes.
could you please repeat the difference between the valve and the tank?
Yeah, you can see we have 2 different. Look at this one. In the system of the supplying water, the water closets we have. Let me say we have western and we have eastern types. Usually the western types is called a flash valve water closet, and for the eastern one is called the flash tank. We have a tank, like there is a tank here and the water closet here. And this is the in the wall. This is the old one, usually. But nowadays we have the system of the WC is together. This is there is a flush tank. There is a directly linked to this. It's called Western one, and it's flush valve. So here's the difference. This will consume 6 fixture unit, and this will consume 2.2 fixture units. So you have to know if this is a Western one and it's a flash valve, then you need to know will use it's equal to 6 fixture unit. Now the bathtub also, we can see we have a bathtub. Here's the bathtub. And the bathtub, if you are using a bathtub, and this is for a private, because it's in my house, it will consider as a fixture unit. Now, so I will go with the one. Will consider as 1 fixture unit. Now I can say the Q here is equal to 6 plus 1, which is equal to 7 fixture unit. Now we don't know what is the fixture unit needs. We need to know how much is the meter cube per liter per second that we need, because we need to know how much is the diameter. This is the design. So what should we do after I'm calculating the load? This is called the load on this line. So what should we do? We should go to another table, which is also submitted or supplied by the code. And this is the second table. After having this one, you will go with the water fixture units. This is the total, the loads. So for my case, I have 6 plus 1, which is 7. Then 7 fixture unit. Look at this one, water supply fixture unit. This is 7. You can say how much is the demand or how much is the flow will needed to be there, you need 1.577 feet cube per minute. Okay, and also we have 7 here, we have 19.8. This is for what? This is for flush valve. Look at this one. It means that if you are using the system of this is for flash tank, if you are using the tank system, the roof tank, and also we have to know here is for flash valve. So for my case, if I'm in apartment and this apartment have no any roof tank, so the total case, the total load was 7, then I will go with this 7, but I'm not using this demand. I will use the demand here, which is equal to yeah, here's 2.6. So 2.65, 2.646, 2.646. Then that's, I will say, because it's, this is in case, be careful, in case that I'm using, if the system is flash tank, it means that like we have it in the compounds and in the apartments, so it means that you have to use 2.646 feet cube per minute. I think here's what this is from the table of the loads. Now this is for what? This is for cold water. Now this is for the water supply that we need. Okay, is it clear?
Yes, doctor, thank you.
Okay, now
Doctor, I don't understand water supply fixture unit. What does that word mean?
it's a
Like,
unit.
how do
It's a unit. It's a unit that
Unit of
used
what,
to
doctor?
see how much is the flow that needed for this pipe. It's units that we have to know how much is the, so the purpose to design of the flow is you should know how much is the Q, right? Q for these two do appliance together, two things together, right? For each of them, it has a certain circumference, circumstances to use. So bathtub and water closet, maybe you need to use the water closet for 3 to 4 times a day, but you need to just use 1 times bathtub a day, right? Now, here's the difference. This is if in case that you are in a let me say it's for private use. Now it means you are using in your own house. So is the Q, is the flow will be the same that we have to use it as a water closet, as a tap? No. So what they innovate a method to calculate the Q for these two units together. How to do that? They converted a water closet to 6 units. Units of what? Fixture unit. It will be, and this is will be as a 1 fixture unit. So the use of the water, or the need for using the water closet water, it will be 6 times much more than the bathtub. This is the one. So what I should do, I will add them together. So this is will equal to 6 fixture unit, while this is will be equal to 1 fixture unit. Adding them together because they are in series, so the load, the flow that's needed to be supplied within this pipe will be equal to 6 plus 1, 7 fixture unit. Now, this is not a unit of a flow, but we have a table that will tell you the total fixture unit will be how much and how much it will be the flow. This table is here, this is the table, which is table, it's called load estimation the demand. The estimation of the demand will not tell you exactly how much it will be for 1 water closet, how much it will be for 1 bathtub, but it will tell you how much it will be for the total load. Now, the total load in my case was 7, but you have to be careful which unit, which type of that building do you have? Is it flash tank or if it's a flash valve? Again, for the flash type and flash, you can go back to this picture. It will tell you what is the difference. This is the tank. It's called flash tank. This is called flash valve. So having this type, it's called flash valve. Here's having flash tank. Now, after that, after you know what is the system, you will go back to the table. The total load was 7. Okay, now which 7 I have to use? This is not used. I will go with this one. And then I will say for having 7, you need to have 19.8 gallon per minute, or which is equal to 2.646 feet cube per minute. Now, this is how to calculate the loads. Now, I want to remind you about the other units, like, for example, dishwashing machine. Dishwashing machine in a private, it means in your house, if it was automatic, you can now say automatically, so it is designed to use 1.4 watt, 1.4 fixture unit. Now, in your, let me say, in your house, you have a dishwashing machine, okay? So that's 1.4. And certainly you have a kitchen sink, so it will be, that will be 1. So both of them, it will be 1.4 and 1, that's 2.4. So 2.4 together, you can say how much it will be the load for 2.4. You have to go back to here. What will be the 2.4? 2.4, because this one, you don't have 2.4 if you have the pressure valve, so you have to use directly to go to 5. So you will say, okay, I will need to have at least 2.005 feet cube per minute. This is not existing, so it's not existing, you have to go with the 5. But in case that you have a flash tank, so 2.4, it will be between 0.064 and between 0.868 feet cube per minute. In this case, you have to do a kind of, it's called interpolation between these two numbers.
Choose the maximum, right?
Yeah, you have to do interpolation to find exactly how much it will be the feet cube per minute that's required for the dishwashing machine and the sink. Okay, it's easy, I think, but you have to first of all to convert over all things that we need to one load. This is called water load fixture unit, and then you will have to go with the fixture unit and see how much is the loads and how and when we have flow here. For example, I have 2.005 feet cube per minute was the needed flow here. Then you will, the Q is given to you, so you have to use a limit of the velocity in the pipes, and the limit usually will be not more. When we have a Q equal, for example, 2 feet cube per minute, so V allowable, usually it will be between 0.6 to 1.5 meter per second. And we have Q and V. You have to find the diameters of the pipes that we have. And after that, when we have a diameter, you have to go and to find the head losses. Head loss is equal to FL over D, V square over 2G. You have the diameter of the pipe, you have the length of the pipe, you have the F, which is the 0.01, and usually it will be 0.01 to 0.1 something. This is as in the Moody diagram. And you have the velocity that we have here. You will find the head loss that will be inside the building. This is the building inside the building, and you can see if it's allowed to have such a kind of head losses or not. So that was my point for today, and this is what we have for the water. That we have the same thing for the For the fixtures, we have it's called drain fixture unit. We have, this is for water. So water supply fixture unit, water supply fixture unit. This is used water supply fixture unit. This is used for what? For water. And we have for the drain fixture unit, DFU, fixture unit. This is used for the design of the sewers. So for the design fixture unit, I think I didn't send you the table. I will send you later. So basically it will be the same. We have to have the fixture, and also I told you that within the checking of the, after you have the flow, you have to check what is the needed, or let me say the pressure at this one. For example, if you have a flow in this two, in this kitchen, it was 2 point, dishwasher machine, 2.75, it said that the flow pressure, the pressure should be at least 8 psi. This is the minimum pressure. So you have the pressure in the, let me say you have a roof built-in tank, so you have the head, and you are sending water from the roof to that dishwashing machine. There will be a head loss. You know, now you design for the, you calculated the Q, you calculated the fixture unit, and you calculated the flow, the load after that, and you know the diameter. So after that, you have to check the head loss. Then you have the head at the tank, and you have the length of the pipe, you have the velocity, you have to calculate the head loss through this pipe. After that, you have to check whether the pressure at this dishwashing machine is stay more than these values, which is, for example, say that 8 psi or not. If it was more than this, the pressure more than this, so okay. But if the pressure this dishwashing or residential area was less than 8, it means that no, this is not enough. You have to solve this problem either to decrease the diameter, or do anything else like. These are all the design procedures that we need. Look at the term of this, lavatory. Lavatory is the one that we are using. Let me say we are. It is a sink, and we are washing our hands and faces. That's called lavatory. Showers is basically what we have in the bathroom, and we have the drinking fountain. Drinking fountain is the device that's used for drinking water, and laundry. We have a laundry tray. This is also another kind of the device that we have, and the others are so sink, urinal also we have it, and usually the urinals will be used in the public ones. And we have the water closets, different types of the water closet that we have. So here's the most common tables that we have. We need it for the design. Any questions about the plumbing? So this is hot and cold water plumbing system. The most common plumbing fixture are bathtubs, bidets, and drinking fountain, kitchen sink, lavatories, or bathrooms and showers, water tap. We have a British unit or faucet, American English, it's called. Terminal values of dishwashers, ice makers, and humidifiers, urinals, and utility sinks, and water closets. These are all the fixtures that we have. We said again, we have to unify all of them together. How to do that? And we have for each of them a unit, it's called fixture unit, and after all, we have to add them together to find the total amount or the load on this pipe and see how much it will be, the total and the flow. The types of the pipes that we are using them for the fixture inside the building, usually nowadays that we have, is the plastic pipes, PPR, and or polypropylene, PP, or PEX, which is polyethylene hexa or hexa and something like galvanized pipe. Usually the galvanized was in the early in the case. So nowadays we are not using the galvanized pipes. It will now it's used for the gas, and the copper are nowadays are not to be, or it's not used. These are all the type of the pipes that we have. Here's the kind of the design should be how much so for the cold water and the hot water, and there will be will be the shower. I have in auto, and this is for the 6 steps of the design after distribution. So we have to have the architecture. Um, architecture. I want to show you some of the AutoCAD drawings about the plumbings. But before that, we have to first of all distributing the fixture in the bath and connecting them with the pipes. So this is the first step, is to connect them and to see what will be the pipes. After that, we have to go with the table of the how much it will be for fixture units for each of them. So after that, we have to calculate the total fixture unit for the whole connected appliance, and after that, we have to know how much it will be the flow in this pipe, and then we have the flow. We have the unit or the acceptable velocity, which is 0.6 to 1.5 meter per second, and usually it will be used 1 meter per second. After that, we have to go with this the last table and go and find for that for that flow, what will be, we have to calculate the pressure drop and then see what will be the residual at each unit. Some symbols are used for the drawing of the AutoCAD when you are using. Just let me see. I don't know, I have a problem with my AutoCAD. Anyway, I will send you typical maps of how to do this one. So it is clear to how to design the plumbing system for a house or a building. Is it clear? Hello?
Yes, sir, it is. Yes, sir, it is. Yes.
Okay. Now, we say that not only the water will be the plumbing, there will be a plumbing system. We have to have a pipes for the ventilation pipe, and this will be VS, vent stock, and waste stack, and we have the solid stack, and we have V. These are the units that we have in the code on the code, and there will be for example, CW, it means that cold water, and SW will be soft cold water, and the PW, which will be a potable water, and HW will be domestic hot water, and it will be hot domestic hot water return. Sometimes there will be a return from when you have chauffage systems, or let me say for mechanical return man TS, which is the tank supply water, and DR drainage, and FF, which is firefighting. Firefighting and the sprinkler systems are also considered as a plumbing system, and you have to, for example, exactly not you, the mechanical engineers will relate it more with this one, but you have to go to see that this is the design of this kind of surfaces to the building's plumbing system is called also plumbing. Here's the diameter. So when you are going to draw drawings, you have to use these symbols inside your drawing. For example, you have to tell the customer that this pipe is CI, which is cast iron, GS, which is the galvanized steel, and we have the BH with the black steel pipe. Black steel pipe means seamless. It's used for the gas supply surface, or and PVC, which is polyvinyl, and so on. Okay, here's all the units that you need to know and you have to be aware where you are using this one. Here's the plumbing fixture in different way. This is called a kitchen sink or double bowl. This is bowl. This is second bowl, double bowl. This is one bowl, single. This is acetic or Eastern water closet, and we have this is the top view, and this is the will be the Eastern, Western, Eastern. And here's the lavatory. This is called lavatory. This is lavatory top view, and this is the lavatory built-in type. And this is the shower. This is the simple that urinal, and this is the bathtub. Okay, this is a kind of when you are going to give a detail for the design, you have to give this type of shapes. You have to say this is the fixture or this is the shower. So this shower should have a hot and cold water. The cold water will be, it will written as HW, hot water. The CW is the cold water, the blue one, and it will be, it's 1/2 inch, it means the diameter of the pipe. Down in wall, it means that it's from up to down, and it will be inside the wall. And also that you have to say there will be a valve here, and there will be a valve, and you have to say that's right. And here's, look at this one. Here's how we have to, for the water closet, you don't need to send cold water, hot water. You just need to send hot water, sorry, cold water, and so. And here's also the design should be like this. And here we have an example. We have this drawing. We have this group of bathroom. We have a Western. This is called Western closet, and sorry, Eastern closet, water closet. We have a pipe that is starting from A, and it will send cold water from A to the shower and lavatory and this water closet, and there will be a tap. Here's the tap. Tap water, it means a sink of tap that will be here. So from A to B, there will be a load. The load will be for this shower, for this lavatory, for this water closet. While from B to F, it will just for only the water closet and the faucet, the tap. For this C, we have only this, and we have only this. Now, what is the required? The required is to, we have, this is all private bath. This is in your house. And the diameters are given to you, and the length is that we have in inch. 3/4 inch, and we have 1/2 inch, and we have 0. And this is the inch, and this is the out diameter, this is the in diameter. Okay, so outer diameter, inside diameter is given to you. Now, what is the required? The required is to find the required pressure at the point used for the details. So we need to know how much it will be, the pressure, and will be after using. So we have to know how much it will be the head loss in these pipes. So the the diameters are given and the lengths are given, by the way. For AB, here's AB. From A to B, there will be 6. From B to E, there will be 8. From B to E, there will be 1. And from E to F, there will be 0.5 meters. So the total length from B to F is 1.5 meters. Okay, and so on. So from B to C, here's B to C, here's this distance. It will be 5 meters, and it will be from C to D, it will be 7 meters. Now, what should we do? First of all, and by the way, the details are given here. So from A to B, you can see from B, this is the B. This will be the toilet, and this will be the tap. So we have, after the water is coming here, it will be the other one, which is 2.5 meters. So the length of the pipe from B to E, it will be how much? B to E, it's 1 meter. 1 meter, it will be horizontally, and there will be vertically, and B to it will be about 2.5 meters. So you have to be aware when you are going to calculate the head loss, you have to have the whole length of the pipe, which is horizontally and then vertically, should be added together. And that's it. Also, another detail that we have it for the shower. Here's the shower. Also, this shower is, we have it, so from C to D is 7 meters. After that 7 meters, we have 2.25, another 2.25 meters for the hot water and for the cold water. So you have to be aware. We have this one, and also we have for this lavatory, we have from C to this lavatory, and then we have to add. This is the length of this one, which is 0.75 meters. Now, what should we do? We should calculate the unit load from what? From the table. Which table? We have the table of the IPC and table 3. And it will say lavatory private. What is the lavatory private load? Here's the lavatory private load. Yeah, this one, this is the lavatory private. You can see there is 0.5. How much is the unit load? It will be 0.5. So that's why we have calculated that's a 0.5. For the water closet, we said that this is a flash tank. It means there is a tank here and it's 2.2. So lavatory water closet, yeah, this is water closet private flash tank. This is for the flash tank, it needs 2.2. It's not a flash valve, it's 2.2 unit load. So after that, I added another 2.2. And you can see for the tap, you have to take it as a lavatory only. So it's also 0.5. And the shower, it will be private shower, and it will be equal to 1. Here's the private shower. Shower head, private, it will be 1. Mixing valve, it will be mixing. It means that you have 1 outlet and 2 controls, one for hot and one for cold water. That will be 1. So overall, how much it will be? We have 2, 2.2, and this is 1, 3.2, and 1, 4.2. Now for 4.2, to get this one, which will, so we have, look at this one for pipe AB, which is the overall, a pipe AB, here's pipe AB. AB will hold all of these fixture units together. So what we have a water closet, we have a tap, we have a lavatory, and we have a shower. So what that means, we have the unit load, it will be 2.2, 0.5, and so this is the one we have, the total. The total is equal to 3.21, 4.2. So this is equal to 4.2. Now, what will be the working load? So working load, it means the maximum. So the maximum one, which is the main B, this one will be the one that we are working on it. It will be the maximum 2.2. Now, what will be the flow for that working? It will be 2.2. We have to go to find this one from the table. And here's the table, 2.2. This is 2, this is 3. So the 2.2, it will be between 5 and 6.5 gallon per minute. So flush tank, yeah. Between 5 and 6, so it will be 5.3 by interpolation. Now the flow will need it 0.003. So this is for pipe AB. Then the pipe AB, here's the pipe AB. Now for this pipe, we have AB, its diameter is 0.75. It means that you have the flow now, you have the diameter 0.75 inch, so you can find the velocity in this pipe. Now check for that velocity. Here's the velocity. It will be by dividing the Q by the pi d square, which comes for 1.7 meter per second, which is a little bit higher than the 1.6, but it will not make a problem. Now for BE, where's the BE? Here's BE. For this pipe, it will have a tab, which is like a lavatory, and we have a water closet. So the unit load of this one is equal to, what will be the unit load? Here, for this one, BE, we have a closet, and we have, so the overall, it's equal to how much? 2.7. Now, 2.7 unit load, or the unified load, but the maximum one, it will be 2.2. You have to work on this one. The working, or the maximum unit load is 2.2, which is the same as 5.3, which is the same as Q. So for this one also, you have to use the same flow here, and we have the diameter for BE. Here's BE. The diameter is 0.7, like we have it in this one. So we can say, okay, for this one, I will find the velocity. The flow will be the same, and the diameter will be the same, and the area will be here, and then I can find the velocity in this one. And the others are the same as in the table. After finding the velocities in each pipes, what we have to do now, I want to see how much is the pressure will be in the pipes. For the water closet, as it's written in the table, it needs to have 20 psi. The pressure psi, or 14 meters. Now what we have we have to calculate the head loss in the pipes and the available head at A. So the available load at A, we have to have this one. I'm going to find so the pressure, I want to see how much is the pressure at E. It will be the pressure at A minus the head loss from A to B and E. So how much it will be the pressure from A to B, head loss to A, B, and head loss from B to E. So adding them together will give you the total head loss. And after that, I will see how much will be the pressure at E, and I will check that with the available one, or the required one. The required one is, it should say, it will tell us that the pressure should not be, the pressure should not be what, yeah, for the shower, the pressure should not be, for the water, it should not be less than 20 psi. Now, I have the length of the pipe, means from A to B, from B to E, and I have the diameter, which is 0.75 inch. I have the Q, which is counted, and I have the C. This is the C, because it's a William Hazen you can use 120, and then after that use this equation. So for pipe AB, here's the length, here's the Q, here's the length, and here's the diameter, and here's the head loss. So from A to B, it will be 0.22, and the total head loss will be 1.32. This per 1 meter, by the way, so we have to multiply the 0.22 by the length. We'll give you this one. And from BE, we have the length is 4 meters. Be aware, this is, we have to go from B to E. From B to E, here's B to E. The B to E, the length is, B to E is 1 meter, okay? And after that 1 meter, I have, this is horizontally, but we have to go 1 meter plus 2.5 meter, that will be 3.5 meter. Then after that, I will go horizontally again with 0.5, that will be 4 meters. So the length of the pipe, here's the length, and this is will be here, and this is will be here, and this is will be here. So we have 0.5 plus 2.5 plus 1. So this is B, this is E. So the total length will be equal to 4 meters. Is it clear? So I'm going to find the pressure at this point. So you have to, this is the pressure at E. I have to see how much it will be the pressure at E. You have to have the pressure at B minus this one. So I'm using the Q. Yeah, that's the 4 meter, and we have the diameter, which is 3/4 inch, and this is the head loss will be per meter. This is by using the equation. So the total head loss will be 0.223. Now the head loss from A to B is 1.3. Head loss from A to B is equal to 1.32, and from head loss from B to E is equal to 0.223. So the total is equal to how much? 1.643. So this is the total head loss from A to E. Now check how much is the available the pressure at A. It should say that there will be a pressure at A. Here's the pressure at A. I think it's, I don't know, it should give you the pipe rig materials. Yeah, it will tell you how much it will be the pressure at A. Then assuming that, yeah, you have to have the pressure at A. And from that one, you can get the total. Yeah, for example, here's the total required pressure should be more than 8. Total required pressure, this is for the first part, second part, and 3 parts. So the total pressure should be more than 8. If it's okay, then you have the pressure at A for 8, then it can be the safe, the system is safe. Otherwise, you can check that one. Okay?
Doctor,
Yes.
is the change in the flow always given? Like, for example, from E to F, we have another flow. It's different from A to B or B to E.
Yeah,
Or we should calculate.
you have to find this one by your own self, because you have to know where's the direction of the flow. It will be from A to B and from B to E. And you can see from B to E 1 meter, and then 2.5 meters, then 0.5 meter, that's 4 meters. So, but the flow, you will have to calculate it through the table. That table will tell you how much it will be. Okay?
Okay.
Okay, I will leave the other part for the tomorrow, and we will finalize and solve another problem with the plumbing. Finally, I want you to study this because it's important.